This is a question from exercise 16.2 Cambridge Admath book, and that is the chapter of kinematics. And this is first question is written here: a particle moving in a straight line passes through the point O. Its velocity v meter per second t seconds after passing through O is given by v equals to 10t minus t squared. This is the expression of the velocity. Let you do this question, and the first question is written there: find the velocity in the find the velocity of the particle when acceleration of the particle is 6 meter per second square. This is the question. So we do not have the acceleration expression. We needed to convert it to acceleration. So we know that acceleration, we are doing the question number A. Acceleration, we can write differentiation of the velocity is called acceleration, d by dt of 10t minus t square, and we got from there 10 minus 2t. This is the differentiation of the velocity, and acceleration given there 6 meter per second. We are going to consider this 10 minus 2 t equals to 6. Let me find out the t value when acceleration is 6. So we can write it 2t equals to 4, t equals to 2. So in 2 seconds, at 2 seconds we can say acceleration is 6. At that time the question is what is the velocity at that time. So now on the velocity, if we put this value of 2 instead of t, 10 into 2 minus 2 square, then we would get from there velocity 20 minus 4, and it gives us 16 meter per second is the unit of the velocity. This is the first part of this question. Then another part, the second part of the question, it is written there. I'm going to use different color for doing this one. B part: find the time taken before the particle returns to O. Actually, if the question is written there, return to O, we have to use the displacement part. It means that when the particle returns to O means displacement, we need to consider 0. In this way we can find out the values, time for the displacement 0. So but the expression is given velocity. To get the displacement expression, we needed to integrate of this expression. Let me integrate 10t minus t square dt, and if we integrate that one, that expression we got from there 10 t square by 2 minus t3 by 3 plus c. This is the displacement expression. So we can write one more line, which is 5t square minus t cube by 3 plus c. Now we have to find out the value of c from here. It is given that the fixed point O, it started from the point O. When it is a fixed point O, that time actually t equals to 0. So we can say when t equals to 0, displacement is 0 as well. So by putting this value in this equation, we can write 0 equals to 0 minus 0 plus c. So we got from there c equals to 0. So our velocity expression right now, sorry, not velocity expression, this is the expression of the displacement expression. So we can write it, we can put it here: 5t square minus t cube by 3, because c we got 0. So this is our displacement expression. Now we needed to use this displacement to get the time, because it is written there particle returns to O, so we need to consider s equals to 0. Let me do that part. 5t square minus t cube by 3 equals to 0. Now we can take t square common, then it is 5 minus t by 3 equals to 0. So either t equals to 0, or another part is 5 minus t by 3 equals to 0, which gives us t equals to 15 seconds. So this is our answer of this question. Hope you understood the questions we have done for you. Let me move to the question number C right now. Question C, it is written there: find the distance traveled by the particle in the second. So we already have the displacement expression, which is s equals to, you can write here, s equals to 5t square minus t cube by 3. So it is written there second, so for second, and the distance traveled in the second, we can write actually s2 minus s1. So this is actually s2 stands for the 2-second distance and s1 stands for 1-second distance. If we subtract from another one, then definitely we would get the distance traveled by the particle in the second. So let me put value instead of t, we can put the value of 2, so which is 5 into 2 square minus 2 to the power 3 by 3. So this is the s2 minus s1, 5 into 1 square minus 1 cube divided by 3. So first second, second, and the third second distance is here. And if we calculate from there, we would get, I think, 20 minus 8 by 3. The first part, just use calculator to do that. 5 minus 1 by 3. So finally we would get from there 52 by 3. Use calculator to do that, minus 14 by 3. And the final answer is 38 by 3. If we subtract from there, equals to 12 over 2 by 3 meter is the final calculation. This is the answer of this part C. Let me move to the question number D right now. Number D, it is written, find the distance traveled by the particle before it comes instantaneous rest. If it is written there instantaneous rest or comes to rest, whatever it is written, always we need to consider v equals to 0 to get the time. So let you consider when instantaneous rest, it means that v equals to 0 always. So let you consider 10t minus t square equals to 0. So if I take t common, then 10 minus t equals to 0. We got t equals to 0 and another value t equals to 10. So the question is, find the distance traveled. So we can consider now from s10, if we subtract the s0, then we get the distance traveled in the by the particle before comes to rest. S10 means the distance crosses with the 10 second, and S0 means distance crosses with the 0 second. So let me put the value in the previous equation. 5 into t value is 10, 10 square minus, this is the expression of the S, 10 cube by 3, and S0, if we put there 0, so definitely it would comes as a 0 by 3, 500 by 3, which gives us 166 over 2 by 3. I did with the calculator. So this is the distance crossed by the 12 by the 10 second of this question. Then the next question, E, it is written there, E, distance traveled by the particle in the first 12 seconds. So there is a point you needed to know, because its velocity equals to 0. We got the value of 10, but it crosses the velocity time. Then we need to draw a diagram. If we draw a diagram, so it say that is the motion of this particle, and we can say this is the starting point, t equals to 0, and at the point t equals to 10, if it is, because it's a turning point, t equals to 10, we considered it rest, means it's a turning point. So then curve turns to here, and here is the particle, t equals to 12. So what is the distance crosses? If we mention here, say it started t equals to 0, then t equals to 10 second, we got 166 over 2 by 3 meter. Now we needed to find out at the point t equals to 12 what is the displacement. So in our main equation, let me use t equals to, I think we have to find out s12 is what. Let me do it. S12, so in the equation we needed to put 5 into 12 square minus 12 cube divided by 3. If we calculate with this one and use calculator again, which is 144 we got from there, and we can mention this is the 144. Now the question is distance traveled by the particle first 12 seconds. So from 0 to 10 second it goes, from 0 to 10 it goes from here to there 166 over 2 by 3, and from 10 to 2 second it traveled this distance. We have to add all the distance to get our total distance. So we can write here distance we needed to add the first 10 second it crosses a distance 166 over 2 by 3, then the difference between these two value, which is 166 over 2 by 3 minus 144, this is that distance. So if we add these two value together, then we will get 568 by 3, or we can write it 189 over 1 by 3.